Nice to meet everyone. My name is Lane. I'm a member of the eWASM team. I'm going to try to moderate by firing some questions at this all-star panel here, and of course giving you guys a chance to ask questions. I thought maybe we'll start. Can we just go down the line? I'll pass the mic down and we can each just quickly, like one sentence, say who we are, what we're working on. So my name is Lane, and other than moderating this panel, I'm working on various eWASM things like testing.
Hi everyone, my name is Hugo. Well, I'm part of the eWASM team. I'm working mostly on the test cases.
Hi, I'm Pavel. I'm a C++ software engineer, and I was taking care of implementations of Ethereum virtual machines from some time. And yeah, I'm trying to do my best here in the also in the WASM project.
I'm Casey. I got spearheaded getting Ethereum.js compatible with Byzantium, and then fuzz testing different clients before Byzantium, and then eWASM since then, mostly.
Hello, I'm Martin. I worked on Ethereum.js and eWASM, both in the beginnings of those projects. Now I'm working on Primea, which builds extensively off the groundwork laid by eWASM.
I'm Everett, and I'm working on KWASM, which is the K formal specification of the WASM VM. So.
I'm Jake, and I primarily work on Hera VM, and yeah, eWASM is what I work on.
Hi, my name is Alex. I work mostly on Solidity and eWASM, and on eWASM work on design, the VM, and the system contracts, usually.
Hi, I'm Jared. I mostly work on testing eWASM, and then in the past I worked on Ethereum testing and Ethereum.js.
Hi, I'm Guillaume. I'm working in the Go team on Geth for Ethereum, and I'm going to port eWASM into the Go client.
Awesome. Thanks for the intro, guys. So as I said, I'll kick off with a couple of questions, try to keep some softball questions in the beginning, and then pass the opportunity to the audience to ask questions. So we've heard a lot today from many of these folks about what we're working on and where we're going. I thought it might be nice to rewind a little bit and just look at how we got here. And I was actually hoping I could ask Casey to talk a little bit about, you hear terms like EVM 1.5, EVM 2.0, kind of what those things mean and how we arrived in this kind of eWASM world today.
Well, I can't speak on all those points. I can just give my perspective. After, because Ethereum.js was, written by Martin, and when he, grew more interested in research than maintaining the client, then it fell to somebody else to sort of, keep it up to date with the latest forks with Byzantium. And so I, picked that up, and then the next project was eWASM kernel, which Martin had also started, and then that became Primea hypervisor, and I had to backtrack in the repo to rekindle eWASM kernel, and that was how I started learning about eWASM. I mean, in addition to obviously asking, and Alex also, Alex and Martin, co-created eWASM, but then it sort of, it languished because people were working on other things, and it languished because it was, it was like 90% done, with the other 90% still left to go, and so, yeah, since then, that's what we've been trying to do is, kickstart that process and then finish it up and make it a, like a working client and a usable test net and so forth.
Can you talk about what is EVM 1.5 and what's the difference between that and eWASM?
Anyone else? Yeah, I think maybe.
I think you'll see a common thread in Casey's comments of other people picking up my Slack. So I just want to say thank you, everyone. Yeah, I got, so. You wanted to, what was the question? Difference between EVM 1.5? Someone wanted to talk about one?
Thanks. Because I'll fall right back asleep after this. It was sitting at about the 90% point, and Martin and I were discussing it, and I was just looking at how could I extend 1.0 to get some of the same benefits without a complete shift to a completely new VM. And so I worked on that, got a prototype implementation done, a couple of EIPs written. And at midnight, somewhere in early June, Christian told me that that project was canceled. So here we are.
So from my perspective, EVM 1.5 is something intermediate step. So it adds some, it makes the end source code and the structure of the program, I mean, it makes the program more structured, so you can at least have some information where the program can jump in and jump out and have some requirements for how items are handled on the stack. So you cannot, if you go to subroutine and you go back, you cannot leave some items on the stack unhandled and so on. So it makes it work more or less as a regular native code. So yeah, it's almost like adding some requirements that are already on existing virtual machines to a bit wild EVM 1.0.
Awesome, thanks, Pavel.
I can add a little bit of historical context to it. So like when eWASM, the first prototypes of eWASM started probably two and a half years ago, two and a half years ago. And WebAssembly back then wasn't really like specified. It was still in prototype stage. And there was no indication when that's going to be final. And then Greg came along, and it's an incremental step, had to improve EVM. So like basically what Greg did, he did all the logical steps needed to make EVM better. And very similar steps were done in WASM. I mean, it kind of similar in several parts. But then I think like early last year, WASM was finalized. And suddenly there was no issue anymore. When will WASM be final? And for some other reasons, there weren't enough resources allocated for EVM 1.5. I mean, this is just a historical context. I don't know the reasons why it was abandoned.
Sorry, our synchronous message passing here is a little slower than it should be. All right, since he's close to me, Pavel, I'm going to fire one at you. You mentioned in the context of EVMC, JIT as an option for implementation. Can you talk a little bit about how far along that is and sort of how well that works and whether that's a reality or possibility?
So I would actually cool it down a bit. So I'm not so sure like JIT is like available at the moment. I would like to know more. I mean, there's definitely a lot of research to be done in this subject. And for example, we want to make sure to actually know what the requirements for JIT would be to be available in this specific environment as blockchain is. So can you actually put it there and make sure nobody will find a way to actually attack the JIT itself? Yeah, so from my perspective, that's something we can try on as a toy at the moment, and definitely lots of research has to be done in this subject, and maybe there will be some stop sign at some point that we cannot move further because we cannot guarantee some properties of process of JITting the code. So that's more or less my perspective on this subject. So at the moment we can spin off the testnet with some JIT as one of the VMs or the only VM to test performance. That is nice to have, but that doesn't mean we will be able to ship it soon. So,
anyone else want to add anything on the JIT topic?
Okay. Yeah. So I had a question because I know. Yeah. Okay. Yeah. I know we had. There were benchmarks done on the compiled.
Hold the mic close to your mouth so people can.
Yeah. Yeah. Okay. So there were benchmarks done on the compiled to WASM, and I know that without the JIT, it takes forever because you have to load up all the WASM code. So it would not, if there's some reason that we could not run it through a JIT, would that be kind of a showstopper for WASM, or?
Yeah, I'm not sure what the numbers we have at the moment. So, if it's
it was like 20 seconds to load it, right?
Yeah, it's not loading the code, but it's actually interpreting how the code is.
Okay.
The pairing. It was the pairing precompile compiled, to WASM, where as native code it takes, 50 milliseconds. I mean, as JITted WASM it takes 100 milliseconds, but as interpreted WASM it took 21 seconds to execute, to interpret the code.
And I think you probably can find a middle ground too, if you're worried about the security of JITting, because there's some sort of attack against finding like a weak spot in the JIT where it's going to be really slow or something. You could probably take approach that other engines use, like V8, where it does a mix between JITting and interpreting, and JITs the hotspots, which is a more complex, I guess, but probably wouldn't have those problems.
So what others actually argue about that is if you have like fixed strategy about when to interpret, when to JIT, that always can be played. Yeah, I don't have my own opinion about that, but there's some arguments I collected over time.
But wouldn't the worst case in that scenario just be interpreting, which is our baseline worst case?
Only if you have like one that is running your strategy for JIT and one that is just straight interpreting. Does that become your worst case? Because you could just stop at a point in the program where you decide, okay, I need to JIT from this point because it's a hotspot or whatever, and then you spend all your time JITting.
Yeah, so the way JavaScript engines work usually is like it doesn't JIT something till it's been hit multiple times. So yeah, you could see it like, oh, okay, that's been hit once and or hit twice, and then it'll start jitting it while it's still interpreting it. So I think that's like a reasonable thing you could do.
Yeah, essentially just run both at the same time, JIT and the normal thing. And if the normal thing stops,
But couldn't you have like a case where, say you have a cache for all the JITted code, and somehow you figure out how to put code into the hotspot which isn't really properly used, and you fill up the cache with that, and then you do another contract which needs to be JITted and is actually executed and is heavy, and you need to keep JITting it every single time because it's not in the cache.
Wait a minute, so what part is not in the cache?
Well, this one which you actually use, so you find a way somehow to pollute the cache with other things which aren't really used or shouldn't be in the cache.
Hey, Greg, you should be on the panel.
I already refused. I would be face down on the table most of the time. If we are talking about running full nodes, strategies like jitting code after it gets caught, caching code which got run, these are highly vulnerable to denial of service attacks. They're only going to be appropriate for light clients.
What denial of service attacks are you worried about exactly? Just filling up a cache?
Jeff had to rip the JIT out of the Geth client in Shanghai.
Oh, that was a multiple. There was several different attacks. Okay. One was like.
Look, do I have to explain, or do you have to do your job?
I'm just saying that I don't necessarily buy that a proper JIT is going to necessarily by itself be exploitable. I think that as Axeth was bringing up with the cache, you probably can set good default behaviors for how to deal with stuff like that. Like if you're filling up the cache, or you notice a contract filling up a cache, you can clear it and mark it as something you don't want to JIT. I don't know. Would that solve your concern?
I'm actually not concerned at the moment.
Yeah. Okay. Me neither.
Yeah. Just to answer, my answer to Jared's question would be that yeah, it is. It is a showstopper if we can't JIT because, one of the major benefits from WASM is not so that client implementers don't have to add new precompiles. It'd be endless, precompile for this, precompile for that. The major benefit of WASM is, it's the precompile to end all precompiles. But it can't do that if it can't be executed in a, as a JIT, as JITted native code.
So I think in general we shouldn't rely on clients using JITs in the first place. And the gas cost should be calculated in a way which map like interpretation more closely than JITting. And if whatever you try to compile fits into the block limit based on that, then you already know it should be able to run on every single interpreter. And if you manage to somehow do a JIT properly, to do that you get a gain on your client. But JITting shouldn't be the baseline we design everything on.
Cool. All right, let's shift gears slightly. I have a question for Guillaume, actually. This is, don't worry, it's so Go implementation of WASM, sort of eWASM. How realistic is that? How far away is it? How much progress has been made? What sort of challenges remain?
Right, so at the moment we are trying to reconfigure or at least reuse some component that already exists. That's called Wagon. It's a virtual machine that was initially intended to execute Go program. Translate them into WASM and then run them. The machine itself needs a significant amount of customization. I'm currently pushing a couple PRs. It's not really complicated, but it's all a matter of getting my PRs integrated, really.
Cool, thank you. Okay. Alex, in your talk, you talked a little bit towards the end, if I remember correctly, about sort of roadmap from here, how we actually get eWASM into production Ethereum. I thought we could just quickly touch upon that again. I know that not everything is decided, but what does the roadmap from here look like, and how do we get to an Ethereum world where we actually have a sort of eWASM engine running, and maybe touching upon sharding, that kind of stuff?
Yeah, I guess like the first part is to finish the design. We have a couple of questions still open there. And once we do that, of course, we have to finalize the Hera, the current VM. Hopefully, we're going to need another VM, potentially the one in Go. And the big parts left out after these, so these are like pretty much finished outside of Go. But the metering, so like the system contracts, and one of them is the metering contract, that should be finished. So that's one of the big remainder parts. Obviously, we need to do a lot of more testing. We only have like a basic set of test coverage at the moment. And there are different ways to increase that test coverage. We could just write actual test manually. We have been doing that so far, but we would like to perhaps accelerate it. And one way to do that is rely on the current Ethereum state tests. But the way we can use those, we need the EVM to WASM transcompiler. And preferably that should be a system contract as well. So that's one of the reasons EVM to WASM actually makes sense right now to focus on in order to make use of all the state tests we have. Now, using all the state tests will not give us a total coverage, even if the EVM state test would have a total coverage on EVM, which probably they don't have. But we have a couple of other things we have to test. Some other options for that, we have fuzz testing, which Casey is involved with. So once all of these testing things are finished, hopefully by that time we're going to have a lot of other customer contracts and potentially like private and maybe a public testnet. And as mentioned, EVM to WASM is probably a part of that. We can already either enable EVM to WASM on the testnet or just rely on the client to have EVM as well as eWASM. So potentially we can have a public testnet which has both. And then comes the actual question, how should this become mainstream? And for that, I don't think we have actual answers at the moment. Initially, probably, again, going back 2 years, the idea was that we would just launch on the main chain. Probably that's less likely to happen at this point. So one idea to launch is to make eWASM part of shards. And the main chain going to be the control shard, and going to stay on EVM. All the other shards going to be eWASM. That's one option. There's no decisions on any of these yet.
You mentioned 2 design decisions that aren't finished yet. What are those 2 design decisions we still have to finalize?
Well, one of them is really simple. Well, I guess there are even more than these, but these are the 2 which are on the plate at the moment. Well, I think even like after today's talks, like Primea talk, we might consider some other changes. But so one simple one was maybe clarify the return value of all these interface methods and maybe unify them. So all of them should have some kind of indication whether they succeeded or not. Or I mean, we just need to specify this. That's a tiny one. There's another design decision we need to solve regarding revert and return, which currently, so we have this revert and return in EVM, which abort execution and set the state whether it was a successful execution and we return something, or whether it was a failure and we also want to return something. Currently, how that maps into eWASM is they are just interface methods and they set a buffer, and it's up to the contract to actually stop somehow. It would be nice to change that so they would behave similarly to EVM. So that I think this is the major one left.
Cool. Any other thoughts on roadmap from anyone else on the panel? Okay, cool. Let's take some audience questions. Who has a question for us?
Thanks. So I had 2 questions. First of all, thanks for all the talks. It's been really nice to hear the updates. The first question was around exactly how metering works, because you said at you can kind of look at different branches of the code, and you also mentioned this system contract that's called out to, so some more details there. And another thing I was wondering about is how does eWASM relate to other implementations of, blockchainified WASM, kind of like parity WASM, for instance?
I can try to answer the metering question. I can try. I might get some things wrong, but basically in EVM, when you execute an opcode, before executing it, you just calculate how much gas the opcode costs and deduct that from how much gas you have available to execute. And sometimes it's variable. It's dependent on current parameters of the state. Like if you're setting some storage location, it was unset before, then you have to pay extra to use memory that wasn't there before. But as Alex said in his talk, this can be be expensive because in between each opcode you're saying like calculate the gas, calculate the gas, calculate the gas. So instead you can take every basic block of code, which is just basically code that will be executed in a straight line, and calculate the gas cost of the entire basic block and deduct it all up front, which is what the metering approach is doing instead. So you find all the basic blocks of your code, which are code chunks that will be executed. If you enter the front of the code chunk, all of the code will be executed, one instruction after the other. You insert the metering instruction at the beginning, which just basically checks, will I be able to execute the entire block or not? And if you are able to, then you deduct the cost of the whole block, then you just execute normally. And then the way this works is instead of instrumenting your runtime to be able to handle that deduction of gas, like you would if you had a direct semantics of metering, you call an external system contract called the metering contract, which just basically keeps tabs on how much gas you have available and deducts it from its store of gas. So it's just a hard-coded pre-compile or system contract that has yet to be released, I believe, or fully developed. It's still in progress, I think, and maybe over time you would update it, and that might constitute a hard fork, I think. Maybe ASIC can clear that up.
Just one addition to that, the really exciting part is that the metering contract itself should be compiled to WASM and should be metered by itself. And then we can charge for the deployment cost based on how much it takes to meter the contracted deployment.
So I can try to answer the question about how eWASM relates to other WebAssembly initiatives such as Parity's WebAssembly. So eWASM and Parity's equivalent attempt to achieve similar things like executing WASM contracts in place of EVM1. And Parity claims to have their WASM stuff going on their testnet in about 2 weeks, I think. We don't actively collaborate with Parity at the moment on WebAssembly stuff, but we attempt to do similar things. What other WebAssembly initiatives did you have in mind when you were asking the question again?
Well, I guess Definity's another one, but I'm just curious if there's design decisions that have been made differently.
Well, about the design decisions, Parity's WebAssembly initiative isn't quite as documented, so at least I personally don't have much vision into what they plan to do differently than we do. And as for Definity, Martin can probably add on to this, but Primea, which is one of Definity's projects, is on a different layer. It's a higher level than just the WebAssembly instruction set. So it can take advantage of the ability to execute WebAssembly contracts, but it doesn't have to be bound to Ethereum specifically. You want to add on to that?
Yeah, sure. So eWASM, pWASM, and I also believe what EOS is adopting, they all have this similar sort of format for their interfaces. Primea takes quite a a slightly different approach with the object-oriented interface that has references. So that would be I think the big difference, right? And just, is there any parity people that can talk more about eWASM?
Yeah, presumably, you know, whatever blockchainified WASM implementation, or you know, if it's not documented, then it's just an implementation. But presumably, there's some host functions, you know, and the you know, the client provides those host functions, and then other than that, you know, it's just, you know, all WASM, you know, the WASM instructions are all the same. It's just how the interface is defined, so how the, you know, the host functions are defined.
So as Martin mentioned, if like parity and eWASM and probably EOS, they follow likely the very same kind of structure. So probably it will be easy to compile a contract to any of those. But Premiere is quite different. So probably you wouldn't be easily able to compile the same thing to all four. But one component we really want to share between all of them, and I don't think there was anyone against that so far, is the metering. Figuring out how the metering should work and the actual metering implementation. Probably there should be multiple of them, but the specification should be very similar, or if not the same.
I think also EVM to WASM will probably work through all of them fairly well. Like, things would break in Crimea for contracts calling other contracts just because the call semantics are different, but like an individual contract I think could be ported over. If you had multiple contracts and you expected them to talk the same way, you might have to also insert some shims, but yeah. So there's, I think, several different components that can all be shared in between it. Yeah.
Awesome. Thank you for the awesome question. Cool. What other questions do you guys have in the audience?
Hi. One of the non-deterministic spots in WebAssembly spec is like how much stack could grow in its limit. And I'm wondering, do you have like a solution for like limiting the stack depth, or you wanted to limit it via means of gas metering?
Yeah, I think we can just limit it by gas metering. If it becomes a problem, like there's attacks against stack-based attacks, then we can just up the price of calls and calls indirect.
Fair enough.
Yeah. Hi, everyone. I remember a time where WebAssembly was also mainly discussed in terms of scalability issues, or for solving part of scalability. I think I remember one blog post some years ago where there were numbers like eWASM could speed up execution by 5 to 10x, I think were the numbers. And in your talks, this wasn't that much of a topic anymore. Do you have any new benchmarks which contradicts the old numbers, or is it just, does it just differ with the sharding plans, and so it's not so imminent anymore, or what are your stances on this?
I think there's one relevant answer to this as well, is the birth of Premiere. So Premiere follows the scalability path. So basically, all the scalability research on eWASM resulted in Premiere. But the way Premiere is designed is not really compatible with the current Ethereum. And I think kind of the reasoning for eWASM shifted from scalability to more like, I think there was a couple of points we have listed in some of the talks, namely that it's a much better base to work off because you can much more easily extend it, introduce new interface methods, or reject old ones, etc. And we don't have to deal like with the basis of the VM. And I think the other important part which we need to figure out there is the instruction set should be much closer to the bare metal. So we should be able to much easier or with much bigger confidence figure out actual gas costs to all those instructions. And it's not even an actual fixed number. It's more like the relation between all the different instructions in WebAssembly which we need to figure out. And you said like it was a 10x increase in speed. I think that's still there, namely just one single reason. It's 64-bit based and not 256-bit based. That should be a big improvement in general.
So yeah, that's, in my mind, I don't consider eWASM to be a pure scaling initiative in the sense that it does not aim to achieve scalability on a very fundamental level other than cleaning up the EVM and making it not this 256-bit word size monster. It's, it definitely is helpful and will make the Ethereum platform much faster because you can do things that you would normally not have been able to, like computation that would usually be handled by the precompiles. And so, again, I consider it more of a speed initiative than a pure scaling initiative.
Yeah, WebAssembly doesn't really help with scaling directly because the bottleneck with scaling is disk I/O. The estimates where, okay, yeah, WebAssembly is 5 to 10 times faster than EVM. I mean, that's true when you're looking at a benchmark. I mean, it's way higher than that if you compare it to a JITted WASM. But if it's just if you're just executing CPU, that's not the bottleneck with scalability. I mean, the bottleneck is disk I/O, and WebAssembly doesn't really speed that up, so it doesn't directly benefit scalability.
So I guess to address scalability is sort of a funny term, or not funny, but like, so, WebAssembly makes things more performant, but true scalability is allowing us to scale horizontally, so being like sharding is scalability. So I think sometimes people get that slightly confused.
So I think someone said Primea wouldn't be compatible with current Ethereum. And if I understand correctly, that's because in Ethereum, the internal calls are synchronous and you can call out to any contract that you want. But in implementing sharding, wouldn't we need to kind of implement, make things asynchronous and potentially roll those other changes in as well to a point that it can allow for parallelism? Or is that like off the table in a fundamental way?
Yeah, I think that's a really exciting possibility. So like, yeah, maybe in the future, even Ethereum could have like a Primea shard. Yeah, why not? You just have to get everyone on board and implemented.
Okay, you guys have to each ask one question. I know you know who you are. Any more audience questions? In the back.
This question is like very futuristic, but do you think you can limit speculation by making like transfers and things more expensive and subsidizing more complex contracts and things which developers are building versus just standard like token transfers and things like that?
Yeah, sorry, could you repeat the question? It's a bit noisy.
So, yeah, maybe can you deter speculation in like the Ethereum network by prioritizing more complex contracts and things like that developers are building apps versus standard like speculation, token transfers and things like that?
So, okay, to make sure I understand the question, kind of incentivize people to build quote unquote real applications, user-facing applications, as opposed to just ERC20 type token transfers. Is that the question?
Yeah.
Speculative execution.
Well, at the moment, I think that's kind of fundamentally difficult because with the current proof of work system, the transactions that actually get mined into the block is, well, dependent on the miners because they choose which transactions from the pool to mine. In proof of stake, this might be different, but yeah, in proof of work, it's definitely very fundamentally hard to incentivize different types of computation. I guess you would start with figuring out which types of computation is which on a quantitative level. I mean, I don't see a specific way to determine just on the bytecode level which computation is important and which computation isn't.
Yeah, I agree with Jake. I mean, it's not the level we'd like to address such issues. I mean, it's not a technical issue, and like building software recognizing intentions, like if you want to speculate your token or if you want, I don't know, buy a Coke in a vendor machine, it will be quite hard. I mean, you don't want to apply, I don't know, AI to that. So yeah, I don't believe that's this basic platform level. It's the place you would think about addressing these issues.
Cool. Yeah. Just to add one quick thing. I mean, I think we have to remember that Ethereum is designed to be a general purpose computer, and it's a slippery slope, right? If we were to begin, prioritizing one type of program or transaction over another, I think it's a slippery slope from there to just general censorship, and I think that the computer is built to be censorship resistant in the first place. I think that to the extent that prioritization occurs, I think it may occur at a higher level. I agree. I don't think it's a technical question. I think you'll see a lot more things like bounties. There's going to be some announcements about kind of bounties and prizes here over the next couple of days that will incentivize teams to build some really exciting applications that need to be built.
I have a question for Everett. Which one's easier to formally verify, EVM or eWASM?
Well, I don't have any data yet because we haven't verified any eWASM contracts. I know that the WASM spec is a lot less ambiguous than the yellow paper is, so that's like a major plus for implementers. There are some weird opcodes in EVM, like mstore8, which make verification kind of a nightmare. So actually, in one of the branches of our repository, we just disallow the mstore8 opcodes so that we don't have to do any reasoning about it, and that makes verification a lot faster. So there's a bunch of little things like that in EVM that make verification a lot like kind of a nightmare, whereas WASM was developed. Well, WASM has an Isabelle model of it already. I'm developing the K model. and it was developed by someone who understands verification. So they're going to obviously have had a lot more feedback into the design of WASM from the start that makes it more amiable to doing smart contract verification. So I think once I have more data, I'll be able to say for sure, but I would say like WASM at this point. But once again, I don't have data to back it up yet. So.
Any other questions from the panel? Do you guys have any other questions you want to talk about? Okay, I've got another one. Would anyone be able to speak? Oh, do we have an audience question? Sure. You go first.
Is there a future possibility where the eWASM interpreter would take advantage of like special features in the underlying hardware? For example, I don't know, you can use the GPU to do video transcoding.
Well, maybe WebAssembly in general. There's like a proposal to add SIMD. So that, yeah.
Yeah, I'd like to add on to that a little. Yeah, in addition to the existing proposal for vector processing in WebAssembly, well, if you have a JIT compiler, like WAVM, W-A-V-M, it takes advantage of LLVM JIT. So when it translates it to hardware instructions, LLVM JIT can understand that these instructions you can automatically vectorize and take advantage of certain hardware features like MMX and the SSE extensions.
Yeah, so I just will repeat the same. If you have smart compiler that it can translate code patterns in WebAssembly to utilize some advanced feature in the hardware itself, I think that comes to the question whether we will use this solution and if it's not some kind of DOS attack vector. So that's the main issue. But if you would use a JIT, like full optimizing compiler as a JIT backend, it's available at the moment. So it's nothing stopping to using vectorized instructions. Not so sure about more exotic features, like, I don't know, AES or something like that for an encryption. It's probably harder to get access to it by injecting code patterns in the WebAssembly, which is how it works. You just kind of go step back, provide some pattern that matches the implementation of the hardware instruction, and compiler should recognize this pattern and replace that with the much more efficient hardware instruction. And the cost of that is also the size of the code on the WebAssembly side you have to keep in the state.
Cool. Any more audience questions?
In this classic EVM, there are these different ways of a contract calling another contract, like call and delegate call and static call. Does these calls translate one-to-one into the WASM world, or is this done in a different way? And in addition, this question was, I think it was posed during one of the talks as well. How can these different EVM types calls interact with each other? I haven't got this.
So the second part, when you say different EVM types, you mean like an EVM 1.0 bytecode
EVM
contract
1.0,
calling
yeah.
an eWASM 1 or vice versa?
And maybe a third question. Does this also translate to the upper level languages like Solidity in some way? But that's another question.
Yeah, all the various types of calls, call code, delegate call, static call, those translate one-to-one to to the eWASM interface methods, the host functions. There is a call instruction in WebAssembly, which is how you invoke another function, or function from some other WASM module. But and you could imagine trying, to map a spec where, that would be equivalent, where that would map natively to calling a different contract. But it's much simpler when trying to have compatibility with EVM to just deal with that at the higher level, at the host function level.
Yeah, so that actually is essentially what Premiere does. It just uses WebAssembly's native call and call-in direct, and has no import. There's no imported function that would give you something like call delegate or call. It just uses WASM's semantics, but yeah, it breaks backwards compatibility.
Yeah, currently we do have these imported functions. And so basically execution starts with a message is coming in. So it's kind of like the same as Premiere, but it's compatible with Ethereum. So say you start executing a WASM contract. That is a message to the VM that this is the bytecode. Is this on? Okay, this is the bytecode, and this is, we need to execute it. And then it can call into external functions. And say if needs to call an EVM contract, it just goes up to the client itself. The client decides whether I want to use Hira for this, or whether I want to use the interpreter, which is already in the client, or whether I want to use EVM to WASM and then Hira. And then the instance is started up. It's run as EVM, if it's EVM, or it's run as eWASM if it's a WASM bytecode. And whatever the output of that is just memory, which is sent back. So they are their own silos, and you can just run them in any kind of chain and structure. There's no, even you could run like delegate call in a way that, say you could run delegate call with WASM and EVM over the same storage. The only thing is they have to access the storage in the same way in order to use this, to get out and save the same data. But I'm not sure if this answers the question.
Yep, cool. All right, I think we're about out of time. Thank you guys very much for the great questions.